So if we look at this problem, we want a number in which it's divisible by 72. And 72 can be split into 8 and 9. 8 and 9 are relatively prime. So first we're going to check, is the number divisible by 8? Okay, it's a number divisible by 8. And that's true if it's divisible by, if you take the number mod 200 is divisible by 8. Well, if we take this huge number, right, and we divide by 200, what's the remainder? Well, the the thousands divide evenly, 10,000s, 100,000s. So you just have to worry about the last 3 digits. And so if you divide by 200, a number in the 730s, what's left is 130 and then the b. So we've got that 130b, and now we can see which of those is divisible by 8. So if we look at what numbers are multiple of 8 in this range, well, we have 120, right? 8 times 15, 8 times 16, 8 times 17, 136. The only one that fits that pattern, 1, 3b, is the 6. So there's what we're looking for in terms of divisibility by 8, is 136. So ending in 6. So now we say, okay, it ends in 6. So this string, these digits, have to be divisible by 9. So we can add up the digits and then see what we need. So we say, okay, we know what we have here. We have this string. We know that the 6, in order to be divisible by 8. And now we say, okay, so let's add up the digits of what we've got now. And we add those up, and we put the 4 with the 6 and the 7 with the 3. So we get 22. So a plus 22 must be a multiple of 9. Okay, so we say, well, the only way to get to a multiple of 9 is 27. We can't get to 36, can't go down to 18. So a plus 22 is 27. A must be 5. So our answer is a is 5 and b is 6. And that would be a multiple of 72.